Another important part of the IEC 61131-3 specification is the description of the following 5 PLC programming languages: ladder diagram, LAD, function block diagram, FBD, instruction list, IL, also known as statement list, STL, structured text, also known as structured control language, SCL, sequential function chart, SFC, also known as graph. The advantages of each of these programming languages depends on the application and the preferences and abilities of the programmer. Because the choice of a programming language is done by program block, the most appropriate language can be chosen for each block based on the task performed by that block. This flexibility is extremely useful, but to take advantage of this flexibility, you need to understand features and capabilities of each language. Ladder diagram, LAD, also called ladder logic, is a graphical programming language originally based on the control circuit diagrams used with hardwired control component circuits. However, over the years, LAD has evolved, and the version described in the IEC 61131-3 specification includes many advanced functions. This means that LAD can be used for much more than the on-off logic for which it was originally intended. Because LAD has been in use for a long time, it is widely used and remains a popular programming language for experienced PLC programmers. LAD is also easy to use for basic control applications, but for complex algorithms, there is another programming language that is more suitable. Function block diagram programming, FBD, is a graphical programming language similar to LAD. In fact, many of the advanced functions used in FBD are identical to the ones used in LAD. In general, FBD and LAD have the same capabilities. However, rather than using contact logic, FBD uses Boolean logic instructions with similar functionality to the logic gates of a digital logic circuit. As a result, many control engineers prefer FBD over LAD. FBD is also easy to use for basic control applications, but for complex algorithms, there is another programming language that is more suitable. Statement list, STL, is a text-based programming language with the same capabilities as LAD and FBD. STL is a low-level language similar to assembly language. STL was developed when PLCs had very limited memory and relatively slow processing speed. Because it allows a skilled programmer to develop very efficient code, it was sometimes preferred for these early PLCs. In addition, because some PLCs had to convert LAD and FBD programs to STL, STL provided an additional performance advantage. For the most powerful PLCs available today, which can run LAD and FBD programs without converting them to STL, the performance advantage of STL is not a factor. However, some programmers with STL programming experience still prefer STL for some applications. PLC programmers who have experience using higher-level languages may find it time-consuming to develop STL programs, especially for complex control algorithms. Structured control language is a high-level Pascal-based programming language. SCL instructions use familiar programming operators for assignment, math, and other operations, and is generally considered the best PLC programming language to use for complex algorithms and processing of complex data structures. SCL also has common program control operations such as if, then, else, case, repeat, until, go to, and return. In addition, SCL has control operations such as timers and counters that allow it to be used for control applications. Because many PLC programmers have had prior training in higher-level language programming, SCL has become a popular PLC programming language. Siemens Programming Style Guide for S7 1200/S7 1500 that SCL offers the best readability among the programming languages and recommends preferential use of SCL for complex algorithms and processing of complex data structures. Graph is a programming language designed for the development of sequential control programs. A sequential control program is divided into defined steps and programmed as a sequencer. The sequencer is executed step by step until completion. Execution of the next step in the sequence is controlled by transitions and step-enabling conditions. Graph is not as frequently used as LAD, FBD, or SCL, but its features make it an option to consider for sequential control applications. A PLC programmer's task is to create programs that function properly and are clear and readable. Program clarity and readability are important because additional people other than the programmer may be responsible for system operation and maintenance. In addition, the program may have to be modified later to add or revise functionality. In addition, in many cases, more than one programmer is responsible for the development of the program code. In these cases, it is also important that all the programmers follow the same guidelines for program documentation. Otherwise, productivity will be impaired, especially if the people on the programming team change. Some of the things that contribute to good program documentation are the same as those that apply to any writing project. For example, proper spelling and writing clear and concise descriptions are important. However, other aspects of good documentation, such as choosing good identifiers, take planning. As previously discussed, a variable name, such as a PLC tag, is also referred to as an identifier. Other types of identifiers include block titles and network titles. Earlier in this course, you learned about the importance of picking good identifiers for tags. Picking good identifiers for titles is also important because it makes the program easier to understand. The rules and recommendations for identifiers are included in the Siemens Programming Style Guide for S7-1200/S7-1500, discussed later in this course. Another way to make the program easier to understand is to add comments for program blocks and networks. The block comment should briefly describe the function of the block, and the network comments should briefly describe the function of the networks. Because STL and SCL are text-based programming languages, they provide additional opportunities for use of program comments. For example, a comment can describe a line in an STL program. Because the line comment comes at the end of the line and begins with 2 forward slashes, it is easy to identify. While you can enter comments in any order as you create or edit a block, following a logical order can help ensure that you fully document the block. First, enter the block title. Then enter the block comment. Next, enter the network title for the first network. Then enter the network comments for the first network. Next, enter the line comments where appropriate. Finally, repeat steps 3 through 5 for each additional network.